Section 5.7 and inequalities. And two triangles. So on Friday, our last class period, we talked about finding out things in one triangle. We talked about the exterior angle theorem. We did a corollary to the exterior angle theorem, saying that the exterior angle is larger than either of the remote interior angles. We talked about how the longer side of the triangle is opposite the larger angle. Medium side of the triangle is opposite the medium angle. Smaller side is across from the smaller angle. And then we talked about the triangle inequality theorem, how the sides of the triangle have to add up in order to even have a triangle. Well, today is all about comparing two different triangles. Rather than comparing one triangle and the parts of things inside one triangle, we're talking about two different triangles. So the first thing we're going to talk about is what we call the Hinge Theorem. So we'll say what it is, and then once we talk about why we call it the Hinge Theorem, hopefully it makes a lot of sense, because it's kind of an easy idea. The other thing you'll hear this called is the side angle side inequality. So for this one, we're going to say in two triangles. If two sides of the triangle are congruent, so two sides of one triangle are congruent to two sides of the other triangle, but the included angles are not congruent. Then the larger side is across from the larger angle. So let's remember, there's one piece here that we need to remember. When we say included angle, what do we mean when we're talking about an included angle? Do you remember what was the other word we used? Everyday word we used for included? Inside or between. So if I have an angle here, or two sides of a triangle, this is the included angle. So it has to be between them. So let's draw a picture here. Once we draw a picture, hopefully this makes sense. It's a lot of words to say, a pretty easy idea. So here's my triangle, and I have these sides are congruent. So we have this congruent over here. We'll call this A, B, C, and X, Y, Z. So we have these two sides are congruent on the two triangles, but the included angles are not congruent. So angle A and angle X are not congruent. So what this is telling us is that if the measure of angle A is greater than the measure of angle X, then CB is greater than zy. This side is longer than this side because this angle is bigger than that. And the reason we call it the hinge theorem is if you think of a doorway, the size of the door doesn't change, the size of the door opening doesn't change, but if we open the door further, the door is open wider. That's what we're saying. The door is open wider when we open the door further. When it's closed, the space that we can walk through the door is very small. When the door is open further, the space that we can walk through the door is very large, or larger anyway. So that's why we call it the hinge theorem. You can also think of the hands on a clock. The lengths of the hands don't change, but as the angle changes, the distance between the tips of the hands changes. When the angle is bigger, the tips of the hands are further apart. When the angle is small, the tips of the hands are close together. So that's why we call it the hinge theorem. And we call it the side angle side inequality because we have a side, an angle between them, and a side. We have a side angle side, but the angles aren't congruent. So pretty easy idea. The bigger the angle, the bigger the side. A couple of things to be careful with here with the hinge theorem, with everything that we talked about today, is we need to know that two of the sides of the triangles are congruent. We need to know two sides are congruent in order to use these things. And then we'll either compare the angles or we'll compare the sides. We'll talk about that in just a little bit. So questions on what we mean about the hinge theorem. Okay, let's look at a couple of examples using the hinge theorem. So for this one, I'm going to say, what else can we figure out? So here's my picture. And we'll call this, we'll say this is congruent like so, and we'll mark this like that, and that like so, A, B, C, and X, Y, Z. So from the pictures that we have here, what else can we figure out about these two triangles? Anybody have an idea? What do you think, Blake? XZ is going to be greater than AB because, what's our reason here? Angle Y is greater than angle C. This mark tells us that angle C is how big? What's a measure of angle C? 90. And this is 98. These other two sides are congruent. So because this angle is bigger, angle XZ has to be larger than angle AB. That triangle is opened up a little more. Questions there? All right, let's ask another question. So we're talking about the ends of the hands of a clock. Are they further apart at 2 o'clock or 9 o'clock? So the tips of the hands of the clock, are they further apart at 2 or 9? Lee says 9. Everybody agree? Evan says yes. So at 9 o'clock, my clock looks like this. And at 2 o'clock, my clock looks like that. Like so. So at 9 o'clock, what's the angle between the hands at 9 o'clock? 90 degrees. And at 2 o'clock, the angle is smaller than 90. So the distance between the tips of the hands, this distance, is larger at 9 o'clock because the angle between the hands is bigger. So the angle between the hands is larger at 9 o'clock than it is at 2 o'clock. Questions there? So hopefully a pretty intuitive idea. The angle's bigger, everything else is the same, then the side opposite the bigger angle is the longer side. Alright, well it turns out that the converse of the Hinge theorem is also true. So let's write the converse of our Hinge theorem. And the converse of the Hinge theorem you'll also hear called the side-side-side inequality. So all we're doing for the converse of the Hinge theorem is we're turning around what we say about the triangle. For the Hinge theorem, we knew about the sides, we knew about the angles, how big the angles were compared to each other, and we can figure out about the sides. The converse is we know about the sides and we can figure out about the angles. So we're going to say for the converse in two triangles, if start the same way, two sides in one are congruent to two sides in the other. But the third sides are not congruent. So we know two sides, and the third sides we know are not congruent. Then we're going to say the opposite of what we did for the Hinge theorem. The larger angle is across from the larger side. So for this one, we know about the sides of the triangles. We want to figure out about the angles. For the Hinge theorem, we know about the angle, and we want to figure out about the sides. Our picture looks exactly the same. We just turn around what we say about the triangles. So we have the same triangles. So we label these ABC and XYZ. And what we're saying here is if we know that side BC is larger, BC is larger than side YZ, then the measure of angle A has to be larger than the measure of angle X. Same idea. This time we're just thinking about the angles rather than thinking about the sides. We know about the sides, and this lets us figure out about the angles. Now, on these, I'm not as worried about whether or not you can name the Hinge theorem or the converse of the Hinge theorem. So if you have to give a reason for something, or for a proof or whatever, if you gave as your reason because these angles one was larger than the other because side BC was larger than side YZ, but you didn't call that the converse of the Hinge theorem, I would be okay with that. As long as we know everything else here, the two sides are the same, and you said this is bigger because angle A is bigger than angle X, I would be okay with that rather than naming the converse of the Hinge theorem. So I'm not that interested in whether or not you can name the theorems. So in the book they'll use the Hinge theorem, the converse of the Hinge theorem. For me, if you said because this angle is bigger than that angle, or for the other one because one side is bigger than the other side, that would be okay for me for a reason purpose. So before we do any examples, let's think about this really quickly about how we could, if we know the Hinge theorem, how we could prove the converse. So to prove the converse, and I'm not going to go through it, I just want to think about it a little bit. To prove the converse, we're going to do an indirect proof. So we prove that if we know that side BC is larger than side YZ, we want to prove that measure of angle A is greater than measure of angle X. So how would we start an indirect proof? So we could assume that the measure of angle X is greater than the measure of angle A. What else could we assume? There are two pieces. We talked about this a little bit on Friday. It could be measure of angle X could be larger, or could it be equal? We're saying this measure of angle A is greater than measure of angle X. Is measure of angle A equal measure of angle X? Would that be, could we assume that for our indirect proof? So we have two parts. So let's look at that part. What if we assume that measure of angle A equaled the measure of angle X? So I'm going to mark my triangle here, like so. So if I mark those two angles congruent, I have a side angle side and a side angle side on two triangles congruent. What does that tell me about the triangles? We have side angle side and side angle side on two different triangles. They have to be congruent. Well, if the two triangles are congruent, what do we know about these sides? They have to be congruent by CP, CTC. Well, if those two sides are congruent, if segment BC is congruent to segment ZY, then we have a contradiction because we're told that segment BC is bigger. So that doesn't work. So that's how we would do that part of the indirect. And if we assume that the measure of angle X is larger than the measure of angle A, what does the Hinge theorem tell us then about this side of the triangle compared to this side of the triangle if this is the bigger angle? It would be larger, but we're told that it is smaller, so that would be a contradiction. So that's how we would prove the converse of the Hinge theorem, do a proof by contradiction. We would say, the conclusion we just came up with would be that ZY is greater than BC. We would say, but we're given that ZY is less than BC. Yeah. Mm-hmm. And that just points out that information is wrong. It can't be because we're told that it's not that way. Okay? So we would do this by a proof by contradiction, show that both, assuming that these angles are equal, or assuming that this one were bigger, leads us to a contradiction. All right, let's look at a couple of examples using the converse of the Hinge theorem, and then we'll talk about the homework from Friday. All right, so we have two triangles here, same picture that we've been using for the entire time here. All right, and for this problem we want to know what are the possible values of x? So we're going to look at this picture and we're going to say, well, these two sides are congruent. This is congruent to this is congruent to that. But we also know that this side is larger. So what does that tell us about this angle compared to that angle? What do we know about this angle? If this side is larger, this has to be bigger than this angle. So that gives us one thing that we can work with. We know that 88 has to be greater than 4x minus 8 because this side is larger than this side. This angle has to be bigger. So I'm going to add 8 to both sides. I want to get x by itself. 96 bigger than 4x. Divide by 4. 96 divided by 4 is 24. Bigger than x. I could turn this around and say x is less than 24. So x has to be less than 24. In order for this angle to be bigger, x has to be less than 24. We need one other piece. We need the other side of our piece. We need a range. The 4x minus 8 has to be bigger than something in order for us to have a triangle. If we have this angle 4x minus 8, it has to be bigger than what angle to give us a triangle? What if my triangle looked like this? What would the angle be? Straight. And so what would the angle between those two sides be? 0. So if 4x minus 8 is 0, I don't have a triangle. So 4x minus 8 has to be bigger than 0 in order for me to have a triangle. So I'm going to say that 4x minus 8 has to be larger than 0. If it's 0, it's not larger than 0, then I don't even have a triangle. So now I'm going to get x by itself here. Solve for x. 4x equals 8 divided by 4. Sorry, not greater than 8. Divided by 4. X is greater than 2. So what this tells us is x is between 2 and 24. And the way we'd write that with symbols is 2 less than x less than 24. If x equals 2, I don't even have a triangle here because this angle is 0 degrees. And if x is 24, then this angle isn't bigger anymore. So I have to get x between those two numbers for this to work out this way. That would be the final answer. X is between 2 and 24, or 2 is less than x, less than 24. And then there are several problems like this that you need to do that they ask you to do in your homework. You always set them up the same way. Whichever angle is opposite the larger side has to be bigger. So we use that to write one inequality. And the angle in the triangle also always has to be larger than 0 in order to have a triangle. So that's always how we're going to set these up. All right, last thing I want to do is a proof using what we've been talking about today. So here's our picture. And we're given that the measure of angle RUS equals 100 degrees, and SU, the way we marked it, equals UT. We want to prove that RT is less than RS. So we want to show that this side is shorter than this side. So let's mark here, this tells us that this angle is 100 degrees. We'll do a two column proof. So we'll start with our givens, that the measure of angle RUS is 100 degrees, and SU equals ST. Those are given. So let's write down. Let's just start by writing down what else we can figure out from the picture here. So what else do we know here? Any ideas? Well, what do we know? What do we know about segment RU between these two triangles? It's the same. So we can say, I'll mark this in red since we've figured that out. So I'm going to say that RU is congruent to RU. And what property did we call that? Reflexive. Good. So the reflexive property. So we're almost done. So now we have two triangles. We have two sides congruent. So we know maybe it has something to do with the Hinge Theorem or the converse of the Hinge Theorem. So we need to know how these angles compare. Well, what can we figure out about this angle? The measure of angle RUT equals what? 80. So let me mark that. I'll mark that in red because we figured that out. And what would be our reason for that angle, the measure of that angle being 80 degrees? They're a linear pair. Well, now we're set. We can say that RT, segment RT is less than segment RS. And what would be our reason here? Angle RUT is less than the measure of angle RUS. So that's where I would say I would be fine with this as a reason. The book would call this the converse of the Hinge Theorem. This angle is smaller than this angle, so this side has to be smaller than this side. So the book would call that converse of the Hinge Theorem. I would be fine if we said that, if we showed that these were congruent, and we said that we knew that because this angle is smaller, that side has to be smaller. Yes? Because these two, this is a straight line, so these two have to add up to 180. So that's what we said, a linear pair, so those two have to add up to 180. Okay? So questions on the proof? I'm just going to put in parentheses converse of Hinge Theorem. All right. So let me